Hi, my name's Ian Miell, and I'm here to talk about Docker, to introduce Docker. So let me give you an overview of what the talk's going to be about. First of all, I'm going to talk about what Docker is, something about my relationship with Docker. So the one-liner is, I've bet my whole career on it, so it better work. I'm going to show some examples of use, take you through some of the sort of technical concepts behind it, talk a bit about Docker and DevOps, show you some Docker files, and talk about some of the challenges around bringing Docker into organizations. But first, I'd like to know a bit about who I'm talking to, because the audiences vary a lot when I talk about this. So how many people here have heard of Docker? Almost all of you. OK. How many people have used Docker? Oh, that's about 15% of the room. OK. That's good news for me, because I can just make up anything I like. And how many of those 15%, how many use it as part of their daily work? Two people. OK, then I'm really safe. And I guess production? None. Wow, OK, I'll put my hand up then. I've used it in production. And I'm guessing none of you are contributors. OK. More interesting question, perhaps. How many of you are developers? Almost all of you. And how many of you would describe yourselves as DevOps? Not many. It's the fashionable thing.
It is?
Yeah. They say put DevOps on your CV, and it means you get an extra 20% pay. Any infrastructure people here? Hooray! Plowing a lonely furrow over there. I started as actually, I'm going to talk about myself in a bit. How many are front-end developers as opposed to back-end? Oh, not as many as I thought. Back-end? Oh, a lot. OK, you're going to love this. And how many people have played 2048 and enjoyed it? Come on. Must be more of you. How many people have not heard of 2048? OK, quite a few. OK, well, you're going to enjoy a bit of this talk, hopefully. OK, so what is Docker? Docker is a technology built on C groups and Linux namespaces that creates containers that run as independent environments on a host machine with a layered file system, avoiding the usual overheads of provisioning, starting, and running virtual machines. OK, so now we all know what Docker is. Thank you. So that's kind of the overview, and some of that may make sense to you, and some of it may not. It's really hard to tell people what Docker is. Really hard. I mean, when I first came across it. So I was, I'll talk a bit more about this in a minute, but basically when I first came across it, everyone was like, yeah, but what is it? And you'd explain this, and they'd go, but what is it? And you'd show them it, and they'd go, but what is it? And this went round in circles, and eventually, people started to sit up and take notice when you actually showed them benefits. And that's one of the key points I wanted to take from the talk. So, I mean, the key thing is it saves you time. If you've had much experience with VMs, and I hadn't when I started using Docker, the thing that people say is like, this is so quick. Like, I can do things I could never have done with VMs. It saves you resources. It saves you money. It enables faster deployment of applications anywhere. And that's the key thing. It's application-oriented rather than machine-oriented. So a VM, it represents a machine, and it's great at doing that. I mean, I remember when VMs started, and they were a very shaky tool to base your business on. This was like early 2000s, I think. And there were all sorts of performance problems we had with it, and we were talking to VMware and so on. But whereas this represents your application. So it's application-oriented, not machine-oriented. And for me, it's been a key enabler for DevOps in my company. I'll talk a bit more about that. And it's really addictive. I mean, when you can spin up environments as quickly as processes, suddenly you're thinking, I can do this and I can do that, and there's all sorts of unexpected things you can do with it. So let's do a quick demo, just so because I could explain what it is again, theoretically, but actually it's probably best just to see it. So let's have a go. at. Can you all see that okay? Shall I embiggen it? Oh, that's too big. Okay, right. So, kill dockers. Right, done. Okay, so I'm in an Ubuntu. Paradoxically, I'm in Ubuntu on my MacBook because I'm too old to learn Mac. I had to get a MacBook recently for my work, but I'm stubborn, so I stuck with Ubuntu. So let's say I want to test something about a Yum install. I've heard there's a great new Yum package, and it's not available in Ubuntu, so I don't want to have to provision a VM. So let's do docker run -ti CentOS /bin/mash. And there we go. I'm now in my CentOS environment. And if you don't believe me, I can do yum update. And there we go. Okay. So there's a few things to kind of say about this. I mean, it looks like a VM. You know, it doesn't look very different. But there's a few points that are quite significantly different about a Docker environment and a VM. So for example, if I do ps-ef, actually I'll go to the top. You can see there's only 2 processes running on this. So it was really fast to start up, but it didn't actually start up anything. Just the bin bash process and my PS there. I have my own network, or I appear to have my own network. So ping localhost and IP root. And yeah, I'm looking like I have my own machine. So it looks like a VM to all intents and purposes. I also have my own file system. So if I do something crazy, oops, and I'm out, and there I go. I'm back in, and we're all good. We're all restarted. So, that's probably the clearest idea of what Docker is. It's a quick way of doing VMs. But people don't like. Actually, no. Another one. Let's do it on. Let's make 100 of those, just so we can see what we mean by lightweight. So that's. Oh no, not that one. Copy. Paste. Okay, so now I'm starting up. Each one of those is a demonized environment of CentOS. So eventually we're going to have 100 CentOS environments to play with. And when that's done, I'll show you that they are indeed separate. So bear in mind, this is not a powerful machine. It's a 4 gig memory, bog standard MacBook Air. And eventually. Okay, let's just Control-C that. Okay, so now we have all these environments. So now if I do Docker, what is it? Okay. So I can run stuff in that environment if I do docker exec -ti CentOS 1, because I numbered them all from 1 to 100, bin bash, and let's touch a file. There it is. And now let's go into CentOS 2. Oh, sorry. Yeah, good point. Oh, I can't from outside. Let's go in there. Right. So CentOS 2, and back to CentOS 1. There we are. So they are indeed separate environments. Okay. So it's quite important to note that it's not an identical thing to a VM. You can't do a snapshot of a running instance and save it and then start it up on some other machine. So again, it's application-oriented, not machine-oriented. Okay. So I got interested in Docker about 2 years ago. I had a ThinkPad that had two important characteristics for me. One was it kept dying. So I had an old-fashioned hard disk, and I coded a lot on the tube, the underground system, subway system, and the hard drive would break like every 2 weeks, and infrastructure hated me. I kind of like, is it broken again? Yes. Eventually, they bought me an SSD, so that was solved. But because it kept breaking, I kept having to reinstall from scratch. So I thought, well, I could learn Chef or I could learn Puppet. And actually, I know how to do this. I'll just write a bash script to do it. So I got really good at reprovisioning my own machine. It also, you think, well, just use VMs. It also had a BIOS problem, which meant that it couldn't run VMs. So these two things turned out to be very lucky for me, because when Docker came along, I was like, this is what I need. I don't need to worry about VMs. Anyway, that's a bit of an aside. So I joined a company 15 years ago, and they did the online transaction systems for gambling across the world. So most of the big gambling names use our systems. And we were 39 people when I started, and when I left, we were 700. So I started as a dev, and then became a tech lead, and then, because I had kids and I wanted regular hours, I moved into application support, trading application support, and eventually became head of DevOps. So, what does DevOps mean? Well, it didn't really mean anything. I mean, it just meant that I knew, I'd basically given myself that job title, and I knew all the different parts of the company and how they work together. And really, that's one of the key aspects of DevOps. So in theory, I was full stack, JavaScript, C app server, I wrote business logic, I did DB optimization. And as I like to say, full stack means you don't understand your software on many different levels. But I could do enough to support it. And I became interested in Docker because we had a terrible situation, which it turns out is not uncommon. I thought it was just us, but it turns out lots of places have this situation where you've got, how do I test this bug? Oh, you can use that environment, but Bob's using it. Or you can use that VM, but don't break it, because they're using it for this, and we can't recreate the state of that. And I was frustrated because I thought, how hard can this be? We can, every now and again, someone has to go and provision a machine. It takes 2 days. Can't they just record their steps and then just one by one reproduce it? And I thought, with Docker, I can really do this. So I had my bash scripts from setting up my machine. I thought, all I need to do is shove it into Docker and then save that, and we're done. And I thought you could apply this to our whole environment. So I got a couple of devs interested, because this was a problem everyone was having, and we really wanted to solve it, and a couple really got into it. And as an aside, and I'll talk more about them later, but there's a concept called a Docker file, which is the standard way of provisioning Docker machines. But for us, it wasn't enough. So we had to build our own, for various reasons, we built our own configuration management tool called Shutit, designed for building monolithic, complex containers. I started blogging about this on my blog, and that's been an interesting experience, as has been running an open source project. And I'm writing a book on Docker called Docker in Practice, which is published by Manning.com. And I've also done a video for Pact Publishing about Docker for web development. So when I say I've staked my career on it, I really have. I also have a new job, which is essentially a Docker job. Okay, so a little bit more around the architecture of Docker and how it works. So one of the key, this is really kind of a primer, so if you get into a conversation about Docker with someone, you can kind of bluff your way through it. A key distinction that people begin to struggle with is the distinction between images and containers. It's not a complicated distinction, but people get confused. Also going to talk about the Docker daemon and Docker Hub and the layered file system, which is actually fairly crucial to its success. Here we've got a diagram which I stole from my book. So up here, we've got your host machine. This, by the way, is the sort of general architecture of Docker as it runs on your system and outwards. So you have a Docker client, which is a very thin piece of Go, and that communicates via a Unix socket through HTTP to the Docker daemon. And the Docker daemon is the broker for all your Docker requests on your system. So it holds all the images, it holds the running containers, and goes off and gets stuff. So when you want to get a CentOS image, so I skated over the bit where I downloaded the CentOS image because that might have taken too long. But if the CentOS image was not cached, it would have gone off to the Docker Hub to go and get it, which is public internet, and then come back down. The Docker Hub is an example of a registry, which is like a GitHub repository, like a GitHub server, Git server. So you could go to a different public Docker registry, and there are many now that exist. So there's like a Red Hat one, and I think there's a Microsoft one, and there's a few out there now. But you can also host those privately. So at my last company, we ran an internal Docker registry for private images. So images and containers. Now, this again is your whole host machine, and on here you've got the image is stored on disk, so it's essentially a file system plus some metadata, and that has these layers, which I'll go on to in a sec, and the containers are the running processes. So for one image, you could have multiple running processes. As we just saw, we had nearly 100 CentOS images running. And those are containers. So fix this, containers, image, right? Now, one of the key things about Docker is the layered file system. And if I jump ahead a little, there we go. When you download, for example, the Ubuntu image, you get roughly an 89 meg blob, file system, tar file essentially, onto your disk, and then on top of that, sorry, at the top there, this is the image of a to-do app that I got from my book, and that sits on top of Node, and Node sits on top of Ubuntu. So the differences between Ubuntu and Node are stored in a layer. And on top of that, the changes for my to-do app, the app code is stored on top as a layer. So why is this important? It means that the amount of disk space you need to represent an application is very low, and you end up with huge infrastructure savings. So in a situation where you have here on the left, you have 9 copy-on-copy containers. So 9 instances of this take up 9 times the space. On this one, you have the to-do app, you have the differences just stored from the first one. So the amount of space you take up is relatively small. And it also means that you can throw these things around really quickly. So for example, I got into a situation where I was fixing a bug with an image, and me and this other developer on the other side of the world, we both had the same image downloaded, and I changed a file, checked it in, committed it, pushed it, and they just pulled that different file from the registry. It took them like 20 seconds, and they could reproduce exactly the situation I had. So separate environments, but very easy to manipulate and share. Okay, so let's show a slightly more interesting demo. So 2048, where are we, 2048? So the game 2048 is, has anyone played Threes on their phone? Or was it 9s or 3s or 3s? Yeah. So this is a kind of a cheaper version of Threes. Let's go copy. So I'm spinning up a Win2048 container. So I played this game and I got to a point where I was always dying. And I thought, maybe I can use Docker to win at this game. Do you remember when you had games and you could save game? Yeah, it was. I thought maybe you can do this with Docker. Just save the game, and off we go. So I've started up this Win container, 2048 container. Let's VNC in. Okay. So now I'm inside a container. I've gone in through VNC, and I can now play the game, although the resolution isn't great. Actually, how do I... Ooh. Hey. Curse as a demo.
You still have about like 50 instances of CentOS running.
Yeah, I don't think that's the problem.
Resize the browser, go to the bottom scroll bar, scroll right, that one, resize the browser.
Which one? The bottom one?
Yeah, bottom there, over there.
Oh.
So that one?
Hang on. Ah!
So frustrating.
This one.
And what to the right? To your right? Farther? Yeah, there you go. Bit down?
Ah!
Bit down? Yeah, click it.
This is
yeah, there you go, just
Oh.
resize.
Ah, good call. You're hired. I, however, am not. Ah, come on. This is the real game now.
Yeah.
Come on.
No.
Oh man. Okay, let's try that again. Okay, so kill Docker. Let's go again. You see how easy it is to recover state? Okay, let's try that again. Okay. So.
Just scale VNC or window.
Just scroll using the arrow keys.
Yeah, it doesn't. See, this is the. Ah.
That's because the VNC screen is larger, so you need to scale it. That works.
Well, this is fun. Here we go. Right. Hey. So now I'm playing. Should we play together? Which way should I go? Up.
Left.
Oh.
The other left.
The other left.
Down. Again.
Okay. So let's say I get to this point and I think, this is, I'm in dangerous territory. I could die soon. So let's try and save the game. Okay. Right. So Docker commit 2048 stage 1. Okay. So I've now saved that. Let's carry on and die eventually. Hey, I'm a natural genius. Here we go. Do anyone remember the movie Daryl? It's about a kid who was a robot and he was just brilliant at computer games. Okay, so game over. So I want to get back to where I was. Let's close this down. And kill Docker. Right. Now, I'm going to restart my container. And let's get back in. There we are, back where I was. I'm not going to try and fiddle around with the browser, the scroll bars again, but you can see that I'm back where I was. And using this technique, I got to the point where I got bored, frankly. But where are we? There we go. I got to the point where I got to 131,000, which I worked out what was the highest tile you could get legally. So that was fun. It was a good demonstration of what Docker could do. And you could do that with VMs. I mean, there's all sorts of ways you can cheat at 2048. But it shows how fast you could iterate. And that was the key thing about it. and how fast you could turn to your previous state.
Does it save the memory as well?
It doesn't save the memory, it saves the file system. So in the file system somewhere is a JavaScript file which stores the state of the game. When you reload the window, it's there. So if you want to cheat, you can just hack the JavaScript. But yeah, this shows how you can do it. But more seriously, at my last company, we used Docker to the point where we were using it for CI. So one of the teams had a complete dev environment built using Docker. And we had the situation where, how many people use Jenkins here? Okay, quite a few. And do you have like a shared Jenkins server?
Yeah.
Yeah, okay, so it's not an uncommon pattern. So we had one of those. It's an anti-pattern, yeah. But these things exist, right? So we had this anti-pattern of a shared Jenkins server. And it was great, we were introducing CI, and like 3 people had Jenkins jobs running on this 32-core machine. It was all fine. Then the Java guys got hold of it, and it was a nightmare. So we had this machine. It was running out of resources. It was busy when everyone was busy. Total nightmare. So this was the pattern. So dev would check in. It would go to the Jenkins server. Job 1, job 2, job 3, job 4, all running on the server. It doesn't scale, right? The other problem was that it was a standard large VM running on a big bit of tin. And you'd go to infrastructure and you'd say, hey, we've got this project and we need Python upgraded. Can you just do that for us? And the guy was like, I'm too busy, I haven't got time, everything's breaking. And I'm not going to change the system, it'll break every other team's system. But it'll be fine. I'm a developer, what could go wrong, okay? So they said no, and I would say, I'll get my manager. And I'm like, okay, I'll upgrade Python. You wait a bit, and everyone's unhappy, everything's broken. So this again is a perfect use case for Docker. So rather than having Jenkins jobs running on a server, you'd have them running on a Docker slave. And that Docker slave could run anywhere. And we ended up using a thing called Jenkins Swarm, which is a really, has anyone heard of it? Used it? It's a really neat Jenkins plugin that allows you to dynamically attach to Jenkins as a slave. So your CI can run basically on remote systems dynamically. And so we had this Docker container, Docker image, which could run anywhere that represented the Jenkins slave. So we started by running it on the server, and then we just said, right, we can just send this out to client machines. So you're a developer working on your laptop, you check in a change, and then it sends the job, the slave job, to any of the machines attached, any of the dynamically provisioned machines. And the nice thing about this is that you could isolate it by team. So you could say, there are 12 guys on the X team working on project X, and the more they check in, the more their machines feel the pain. So it scaled with the development effort. The more developers were in, the more compute we had to play with. And that was a really nice illustration of how Docker can make certain things a lot easier simply by being able to move environments around. So in introducing Docker at this corporation, okay, another question. How many people work in companies of more than 100 people here? Okay. How many more than 50? How many more than 10? Okay, so between 10 and 50 is kind of the norm. So it's one thing to introduce a company, a technology in a room full of like 10 hackers. 700, it's very different. And so trying to introduce like Docker and then the idea of microservices, which Docker goes hands in hands with, was really a big ask. So the first problem we had was how do we get our 15-year-old software stack useful with containers? And we were told by everyone in the community, like, don't put everything into a container. You should have microservices. You should rewrite your entire system to make it work in this way. And I said, that's not going to happen. So the question arose, how do we do this? How do we shove everything into a container and just make it a useful environment for us? And the general answer was Docker files, which I'll talk about later. What Docker does is it separates build from deployment. So traditionally, you have tools like Chef and Puppet and Ansible, which are designed to maintain a running system, a moving target. So you declare, I want Apache on all my machines, and it goes off and figures out how to achieve that. But what Docker changes is, or what it can change in effect, is something called Phoenix deployment. So the idea is that you rebuild from scratch regularly. And because you're rebuilding from and to a known state, the environment can be more easily shared with other people. And as an illustration of this, so one team at my last place, they had a daily rebuild of their entire development environment. So they had like data, all their applications, they had endpoint testing on all their applications, everything built in one container every day. And at first, people were like, no, it's okay, I've got my VM, I know what state it's in, I've got my laptop, I know what state it's in. But as they went into a new project, they were like, oh, I need to set up another environment. That thing you've got over there, and they were finding it was built every day, which meant that they could just get the new one every day, check it out. If they fixed something, they would fix the rebuild process that we had, rather than just fixing it on their machine, and everyone else would benefit. So you got this kind of continuous development environment process going. And it meant that people were iterating so much faster for development and not having to remember how to install MySQL or configure this or configure that. They were encouraged by this process to not deviate too much from the standard branch. So I have a website which I built called themortgagemeter.com, which I can show it. There we are. Excuse me. So I built this website to track mortgage data in real time. And the basic idea was I wanted this graph, which was real-time historical averages of fixed rates. And I also wanted to learn Angular, and I wanted to do all sorts of other things. So I built this thing a few years ago, and then I learned Docker, and I thought, hey, I can actually just because I had all sorts of problems, like I would spend 6 months not developing on it, and then go back to it and be like, what state is this in? And I had to do an apt-get upgrade, and everything would break, and it was just a total nightmare. So I thought, well, if I rebuild this every day, including the data and everything, then I'll know what state it's in today. And if it breaks, I'll know why it's broken, and I'll be able to test it every day, and so on. So every day at 4 o'clock, it rebuilds from scratch, everything, including the data, and swaps the new one in. So, I occasionally have a disaster, like when Ubuntu dropped support for a version of Ubuntu that I was using, and you do an apt-get update and nothing happens. You're 404. But because it happened so soon before my build, I just asked around, and everyone's like, "Oh, didn't you know Ubuntu's out of date? That version of Ubuntu is out of date," and so I could fix it really quickly. And I only had one of these problems to solve on that day. Whereas if I'd waited 6 months, there could be all sorts of things changed, and I'd basically have to start from scratch. So that was an example of, and I've blogged about this and other things that have happened with Phoenix, actually using Phoenix deployment in my production system. But this mindset change is, I think, one of the key takeaways. When you start doing this fast iterative build of environments, you stop thinking about making changes to the environment. You think about changing the way the environment is built. So I'm kind of running out of time, so I'll skip over that. And yeah, here's another kind of illustration of that. So Does anyone remember a time before source control?
Yeah.
It's hard to believe now, isn't it?
Just work in the end of it. Never hard to believe.
It's hard for me to believe that I once resented CVS. You know, we had tar files and we copied them up and we untarred them, and what's the problem? And the CVS thing, it seems so fiddly, it's so painful. I'm that old, okay, so I can remember that. And then your configuration management becomes a backup. So we screwed up a release with our tar files, and we said, no, before we untar, we should probably back up. And then, you know, we finally gave in and used source control in about 2001. And then some years later, you get to the idea of continuous integration. So you're constantly rerunning tests in the background and hopefully responding to emails that you get, although in my experience, people generally don't. And then you get to continuous delivery, where you're applying that continuous principle to a live environment, which is changing. And then I think you get to Phoenix deployment, where you're rebuilding everything from scratch as soon as possible. And I talked about this once with a DevOps guy at one of our customers in my last place. And he said, oh, it's the elephant problem. I said, well, what's the elephant problem? He said, well, you're in a village in, you know, some middle of nowhere, and it's in Africa. So you've got monkeys, you've got lions or whatever, you've got wild animals. And one day a monkey comes in and he just kind of cuts a child, or you know, there's a problem. So you think, right, we'll put up a fence. And then like a lion jumps over the fence or whatever, jumps over the fence and eats another person. You think, right, okay, bigger fence. And then electric fences. And then you just build up all this stuff to protect yourself from these problems. But then every 3 years, just a herd of elephants just walks right through your village. And you can't defend against that. And he said, you know, continuous delivery is great, and then there's a bomb, and what do? You have to rebuild from scratch, and how do you do that? So I think that's the future. So Docker files, right, let's get on to Docker files. Has anyone seen Docker files before? Many of you? A few of you, yeah. So a Docker file is it's a very simple looking thing, but the idea is that it's a very reliable, reproducible way of building your environments. So you start with a from statement, which says, go from this image, in this case Debian, and then you run some commands, you copy in a script, you change the chmod that script, and then you define an entry point, the default thing that runs. So in this case, this was a script that I wrote to send mails out using Gmail. Because I kept having to set this up on multiple machines and I got fed up, so I did that. So if you ever end up writing Docker files, you know, keep them small if you can. There is, as I've talked about, microservices. It's a key thing. The question then becomes, if you've got all these little services running, like an Apache and a Redis DB or whatever, you have to orchestrate them. And that's where Docker Compose comes in. So Fig is formerly known as Fig. Docker Compose allows you to orchestrate the different containers that run in your system. Docker Compose, it's worth noting about the ecosystem that it's in a massive state of flux. And there's tools coming out all the time. And Google have come out with a thing called Kubernetes, which is a nice Greek word. And it's available, you can look at it on kubernetes.io. But they have a rival concept called pods, which is a grouping of containers. And Google used this as part of Kubernetes to allow you to manage services in a cluster. So you define your pod, and you say, I want 3 pods of this web service running across our system, and it'll go and figure out where the best place to put it is. So there's a lot of interesting stuff going on around that, but it's still quite immature. We're talking about the registry as well, the Docker Hub. So let me show you it. So there's, oops, where are we? Docker Hub is quite slow, it has to be said. Okay, let's come back to that. Okay, so I'll go back to that in a bit. Challenges. There are a lot of challenges, as I've talked about, in introducing Docker to a company. The big one is security. So if you're in an enterprise environment, then Docker itself is not secure. If you give someone the ability to run Docker, you're kind of giving them root on their machine, which may be fine for your organization if you trust everyone, but it can be very dangerous because you might download an image, and this has happened, you might download an image that has something malicious on it, and then you're in trouble, potentially. So beware of that. There are things you can do about it, but they're quite involved and complicated, and I'm dealing with them right now with my security team. But that's the takeaway from that. The other thing is the mindset. We talked about Phoenix deployment. Has anyone here read The Goal? No? Has anyone here read the Phoenix Project? I can really recommend both those books. They describe very well the problems of running IT systems. The Phoenix Project is about an IT system. The Goal is a book written in the 70s by a guy who runs a factory. And he basically uses essentially old DevOps principles to run his team. So he has to measure everything. He goes and checks the reports, and he finds that the numbers are wrong. He pulls out an old robot from like 20 years ago because it actually runs faster than new ones that they bought in last year. And all these things have direct parallels with IT. And I found that book much more interesting than the Phoenix Project because it showed you that this is a universal set of problems. So Docker's like the new robot in this world. There's also a change in mindset in terms of how people collaborate. So where I've worked, you've got this idea of the Docker contract. You have to establish this idea of the Docker contract that you send an image to test, and they look at the image and they run it, rather than you have to talk to each other and have all this noise around sharing. You also need investment needed to implement. I've talked about the ecosystem and how confusing it is. It's really Wild West out there. It's really unclear who will win the battle for orchestration, who will win the battle for even containers themselves, because Rocket's another tool that's coming along. And you have to figure out who's responsible for what in your organization, who's responsible for building them, who's responsible for running them. How do you separate those responsibilities cleanly? All that sort of thing. And data is the elephant in the room. So data does not move the way containers move. But this is a problem we've seen with VMs in the past. I think I'll stop it there because we've got 10 minutes for questions. Does anyone have any questions?
There's a question over there. You can have 5 more minutes, I guess. You don't have that many questions. Let's do that one and then decide.
Okay. So the things I've learned from the last 2 years of doing this is that generally people don't want to change the way they work. Even quite motivated developers are very blinkered about learning new stuff. So I love to read Hacker News. I love to try out new stuff. Docker's great for that, by the way. You want to try out a new app, you just Docker pull it, play with it, throw it away. It's great. People are very reluctant to do that, even if it will help them do their job better. So you have to make it really ultra easy for them to use this. In fact, you kind of have to do their job for them. But once they get it, they really turn. So that's something I've found. You have to get motivated people to help you change the way people work. So there were a group of 3 of us at my last place, and we used to go to the pub together and like complain about how no one was changing. And eventually it happened. People don't get it until you do it. So I talked earlier about, it's a VM, right? And you have to kind of explain the differences. Some people will never get it, and everyone else around them has to change before they'll actually jump in. And I've had to learn a lot of technical stuff because Docker touches on sort of every part of the software lifecycle. So things I wasn't really interested in before I had to learn about. So that's been a great experience. And as a final note, there's some other interesting stuff coming out of the whole Docker world. So we're seeing more and more minimal OS operation systems. So we've got Core OS and Project Atomic, which is kind of Red Hat's answer to it. Core OS is a very minimal operating system that basically just runs systemd, and everything runs in containers.
Yeah, but systemd is the word.
If you like, yeah. Which is interesting to me because it's sort of like getting back to the old microkernel argument between Linus and Tannenbaum. You know, I think it's quite an interesting development that we kind of get away from managing this big monolith and going to like discrete components. I'm working a lot with OpenShift at the moment, which is a Red Hat product, and it's looking really good. It's a way of managing applications across the data center. And there's this whole idea of the data center as an operating system, which is exemplified by things like Mesosphere and Kubernetes. This idea that you don't think about machines, you think about data centers as a single unit. That's a really interesting idea, and Docker's going to help with that. Okay, any questions?
Wow, okay. There's a question over here. Let's.
Hello.
Hi.
Thanks for the presentation. I have 2, 3, or 4 questions for you. It depends on your answers.
Okay.
First of all, I'd like to ask you, we fire a Docker instance, and this is a running process, isn't it?
Okay, that's, yes.
Yes. So, what
in the pure state,
it has its user space in the kernel.
It's just like a process, any process running.
Any
on your
process
OS.
running, yeah. What happens if the host machine is unstable? First of all.
In what sense unstable? Do you mean can you be affected by other programs running on the system?
For example, if we have an application which depends on a database, which depends on another application, and we have, as far as I understand, we have one Docker instance for our application, let's say for a Jetty server, another Docker instance for a MySQL database, and another one for a Memcached cache. What happens if any of that fail?
Okay, so there's sort of 2 answers to that. So essentially the question is, how do you orchestrate these things? Yeah.
Oh, these are the orchestration.
Yeah. So you can either treat your containers monolithically, like treat them as VMs.
Yeah.
That's considered bad in the community, although I've never really got to the bottom of why it's so bad. And we've been very happy with monolithic containers up till now. The alternative is to run separate containers, and you can link them together. So you can effectively wire them together such that they all talk to each other. And you can also manage them so that if one dies, the others are brought up. That's what Docker Compose helps you with.
Right.
So you can treat these different services as units within your set of containers.
Right.
Does that answer your question?
Yeah, partially. What happens to the data?
Good question. Yeah, it's a very good question.
Because you said that we can deploy databases, entire operating systems.
You can. The data is still there on the disk. So fundamentally, you can always go out and dig up the data, unless it's corrupted. The alternative is to regularly commit the data containers, or you can mount out to the file system if you want. And most people will do that. They'll have a DB on the file system on the host machine, and the containers will connect to that.
So we create many mounting points on the file system, and all the Docker images point to.
Yeah, because your images should be stateless. So your stateful information you probably want to manage outside Docker. But
thus we can recreate it from zero, from non-existence, as you said. Your example recreates itself again and again.
So I didn't take that approach with that. A database fundamentally should be reproduced from scratch. That's what logical logs are for. So that's kind of the state of that is managed by the database engine that you use. But these are the kind of waters you get into when you start looking at how to actually run these things. And data is the big is the big question.
And the final question, when, as far as I understand, if we want to escape from the monolithic approach of a VM hosting the server, the database, whatever, we split every single developing unit into a container, aren't we?
Well, the official line is every service.
Every service.
So that could be quite a complex thing under the hood, but the idea is that it's one exposed thing.
Oh,
is the idea.
Not just the Linux service or Windows service.
No, just your semantic service, so the thing that you're serving out to the world.
Okay.
So you can twist that and turn that into a monolithic container if you want. Okay. But in my view, people worry far too much about these kind of philosophical problems. You know, once you start saving money with this stuff and improving your DevOps process, no one worries about these philosophical things anymore.
Okay. Thank you very much.
Okay, next question over here. And can you speak up a bit, by the way? We can't hear you back there. Yeah,
okay.
Adjust your mic.
Buongiorno.
Hi.
What kind of files does Docker saves in the file system, in the host system?
That is another. Is that better? Yeah, that is another tricky question. So Docker, you can do everything from forgetting about the copy on write stuff and literally copying everything over for each container as raw files. But Docker has a concept of a storage driver. So you could have AUFS, for example, is one storage driver, and that copies whole files on write, which is a problem if you have large database files. So we had like 2 gig files, and it would just take ages for them to copy over. You can also have it at the page level. So I think Device Mapper is at the page level. But that is an interesting area. I wrote a blog post on it. So if you have some views on it, I'd be really interested. But you can actually have different storage characteristics for your Docker containers depending on your use case. So you might want to optimize for speed of copying, or you might want simplicity, or you might, just want to take the default.
Right. Okay. We don't have time for any more questions. Thank you, Ian.
Thank you.
Please,